Hello everyone, welcome to Recitation Zero on debugging. I'm Joe, and I will walk you through a toy example of MNIST classification to kind of see what you might be looking for when you're debugging. Okay, and let's start with it. So there's many kind of problems that you uh, might meet when you're doing the homework part twos. And one of uh, the most likely problem that we will see, especially when you're halfway implementing your model or dataset data loader, is that there's some shape mismatch of the tensors uh, between the tensor from the data or some intermediate calculation steps with your model parameters. And let's take a look at this toy example. It might sound a bit complicated to you at this point, but trust me, after you completed like one homework, you'll find it familiar. And what I mean by shape mismatch is, for example, in this training loop, uh, these two values will be a torch tensor. You can go to take a look at the torch PyTorch recitation zero video if you want to get familiar with this. But yeah, so when you take this from a data loader and you pass this through your model, uh, it goes to the definition here and calls a forward function, right? And each of this is a PyTorch module, which contains some parameters. As for example, for a linear layer, you will have a bias, you have a weight. You see this in lectures. And when they do calculations, they do a matrix multiplication or some tensor multiplication. Like matrices are two-dimensional arrays, tensors are multi-dimensional arrays. They follow a certain rule when you want to do multiplication between them. And when if you make some mistake in your code, then they will have shape mismatches. For example, when you do matrix calculation, the number of columns in the first matrix has to be the same as the number of rows in the second column, right? Uh, Rules like this, we'll fill them, PyTorch will give you an error complaining about this. And when you're confronting these kind of errors or bugs, what you want to do is that you want to use Python debugger to set the breakpoint in this forward function or in any function that you suspect that you might have made a mistake on the shape of the data. And talking about the Python debugger, the second part of this video will be discussing that. So just keep this in mind. And let me tell you that the Python debugger will set the breakpoint here and allow you to walk step by step in your code. So what I mean is that, for example, if I set a breakpoint here and I execute the program will stop here and ask you to go step by step in these operations. And after you execute each step, you can print the shape of whatever variable that has been defined in the runtime up to that step. So for example, when the breakpoint is here, I can check X, I can check the parameters in the model instance, and after I run this step, I can check out, right? So by this, you can literally inspect the shape of every variable that is involved in the calculation of your model. And this is mainly how you will be very like this is just the way I at least I do this personally. And I think it's very helpful, it's very convenient to check like shape mismatches. Okay. And aside from shape mismatches, uh which is like the kind of mistake that you made when we were still implementing your model. And let's say that you now have finished implementing it, you train it, and you test it, and you see that the result is garbage. So what might be wrong? And in this case, there's a like kind of a very subtle problem, right? The program doesn't make a mistake, which means that the calculation is fine, but you still get very bad performance. And so the number one thing to check is that if you are working in a study group or you're in a mentor group, you should probably check your hyperparameters with your teammates or with the TA, your mentor, or like in any office hour. So what are hyperparameters? Like for instance, in this toy example here, this are some metrics of the model. So for example, input hidden size which you will learn shortly in the lectures, is the size of the linear layer. Uh, the size of the weight matrix of the linear layer aside from the input size. Like the input size is the size of the input vector. And number of epochs, how many epochs you want to train the model. Like one epoch correspond to going through the entire training data set, right? And batch size, literally the size of the batches, and learning rate. Like these type of parameters can cause like kind of big differences in the final result. And most importantly, even if you have the same set of parameters, uh, unless you set the same random seed, otherwise you still get different results even between different runs, even when you are using the same number of hyperparameters. Okay, so this is number one thing to check. Check your hyperparameter settings. Make sure that it's making sense. And if it still doesn't work, then you have to go deep into how you define your data set and data loaders. And in this toy example, because MNIST is like a very well-known intro level data set, it's this example here is like pretty well packaged. So it's not actually writing a custom dataset data loader for that. I'm not sure if it's introduced Recitation 0 for PyTorch. You can go check it out. But what that is, for example, in homework one, you will receive like a lot of like for example paragraphs, and what you're gonna do is that you're gonna cut off certain sentences instead it and make them into fixed length batches, and which means that the data is not ready for you to use. You have to curate them from like a larger raw data set to train your model, and in that process you might make mistakes, right? So for example, you're predicting a label for I don't know, like for example, you have a few vectors, you have a few labels for that, but you have to curate them from the raw data set. And if you make a mistake in that process, for some reason the data you generated doesn't have the correct label for each vector, then imagine in this case, even you have the best model, your performance, like your result is going to be very, very bad because your model is not trained to predict the correct stuff, right? So this is the most important thing to check. When you make a mistake, like your model runs, you get a result, it is garbage, and the first thing you have to check is that you're making the data set correctly. And how do you do that? Is there's always something like a training loop or a training function in the homework where you call the data, you load the data from the data loader, and you run it. And you can inspect the data at this point by setting the breakpoint I said earlier, right? You stop here, you print whatever is loaded, and you check what is returned by your model to see if it makes sense. And the second place you can do this is in the data loader function. In the dataset class, there will be, like, if you want to make a custom PyTorch dataset class, you have to create a method, just a function for the class called guide item. And there you can also set that breakpoint and check literally how you create your data. And yeah, so once again, setting breakpoints are very important. I think there's something similar, a similar tool in C, uh, like this. Was it GDP or something? Like something like that. So you set a breakpoint, allows you to execute step by step, very important. And this is about data. And if your data is fine, then what you should check is your model, uh, which is right here. Um, Initialization function, you define the parameters, and maybe do some pre-processing if necessary. And for function, you calculate like you actually do the calculations. Um, in the first homework, the model is quite simple, but yet you might still make mistakes. And in the later homeworks, the model can be pretty complicated, especially homework 3 and 4. And maybe also too, like you will be following the model definition in some research papers, and um, you might make mistakes. So you really want to pay attention to that. Make sure that you don't make any define, there's no any difference in your model between what between your model and that defined in the research paper. Even in some activation functions, the order of calculations, like right here, the first step is the linear layer, second step, the activation, the third step, another linear layer, right? Like don't like you might see dropouts, you might see normalizations, batch norms, layer norms, like don't change the order. And because the model is a black box, you change it, you might get like a very different, very bad result. And we do have some like intuition like explanations intuitionally, but that's not math, that's not rigorous. So the safest way to make sure that you don't make any mistakes while debugging is to make sure that you write the exact same model as described in the research paper. And to do that, you get the help from debugger again, right? You set a breakpoint, check every step, make sure it's like, there's like no apparent mistakes, and you want to debug like that. And finally, if you see NaN values, like NaN, NaN values, something like this means an overflow. Like for example, if you divide by zero or make some like stupid mistakes, not stupid mistakes, like some math errors, you might likely get a NaN value. And the most likely cause of a NaN value is that you have a too high learning rate, like right here. Um, if your learning rate is too high, you will learn, which the problem is what we'll learn in fifth lectures when we're doing gradient descent. Your learning rate is too high, then you have a step size that is very, very high, and which will make you oscillate like randomly, and it's very likely that you get overflow in a value. So if you have an n value, the first thing you should try is to decrease your learning rate. And if that doesn't work, you will go back to the step two and step three we just described. Like check your data, check your model, set breakpoints at any step in your calculation. Like for example, in the for function or in the get item function of your dataset class. Like to go stop every step and take run your training loop here, get your data, and then you set a breakpoint. For example, here in your forward function, you run step by step and check at which step you get the NaN value and you try to fix it. Okay. And I think these are the few issues that, in my experience, you might encounter as a student. And if you have any question when you're doing the homework, don't hesitate to reach out to your team mentor, or just show up in any office hour, and there will be people trying to help you there. But I do recommend you to like spend time to do what you can do and then reach out for help, which is very helpful for our work, our task, because there will be a lot of students, and which will also benefit the most for your own learning experience. Okay, see you later.
So welcome to the PDB portion of this recitation. So we're going to be showing you how to use the Python debugger. We can simply start by using pip to install the PDB and then pp. You can see that we have that installed. And one little trick that you can do to check imports if you have like a lot of installs and imports running, you can enter the Python interpreter. You can just try import and then the module that you're looking for. You can see that's pretty quiet, which means it's a good thing we imported that properly. If we try importing a module that like doesn't exist, or I don't have it installed at least, like cookies for example, you can see we'll receive a traceback error, which means that that module isn't found. So we can start trying to run this example. We can do python pdb example, and all right, we're already hitting errors. So we'll start using pdb for this. You don't always have to, but I personally prefer it and always recommend it. We can import PDB, and then you can actually just put a semicolon just to make it clean. PDB.set trace. This is nice because it's inline, and then you'll know exactly where in the code it'll stop. You can set multiple of these if you want. If you run this, you can see we've just stopped here at this results. You can do list space dot to figure out where you are in your code. So we're in this like line 32 area, which is right here. We are right before the execution of this line. So we can actually just step through code one by one, which is a nice thing. So what you can actually do is next. We'll try that out. But you can actually see that we've hit an error. That's because this error occurs somewhere in this function. And when we do next, we actually execute the entirety of this function and then try to move on to this next line at this higher level. So I'll stop this, and then we can try again. And what we'll actually want to do is do step with s, and then you can see we've actually entered this run function. So let's do list dot for where we are. We're at like line 8, for example. So let's actually scroll up to line 8 here. So now you can see we're in this general area. Let's do next because I don't want to enter in any functions anymore. Space dot, we're right there. So let's try next again. And all right, now we're hitting a value error. So we know that this is happening right at this line, line 9 that we were just at. And we have a dimension mismatch. One thing that I always like to do with dimension mismatches is just print out the shapes of whatever I'm working with. So if we're multiplying A by self.batch B, what we can do is print A. And the nice thing about this is that you can also just kind of write a little bit of code while you're debugging. You can also like transpose it if you want, but that's not super helpful to us right now. We can do a dot shape print for that. And you can see that this is our A shape. Kind of fitting because that's right there, but it might be helpful if you don't exactly know what your shapes are. We can also print self.batch_b.shape and figure that out as well. And okay, we have this issue. And for matrix multiplication, you have to remember that like the last dimension has to fit with the second to last dimension. So what we can actually do is just in here, let's just try to write a test. A times self.batch_b, and let's try to transpose it. Let's see what happens. All right, there's a matrix multiplication issue there. So we can actually go into this a little further and try this out, dot t, and then we can try to print the shape as that's the result of this. So now that's our issue. What we actually want to do is just rearrange these last two rather than basically reverse all the dimensions. So we can try self.batch b dot, and then I'm just going to go ahead and use the transpose method. So I'll keep the 0th axis, I'll put the second axis here, and put the first axis here. Let's print the shape of that. Now this looks like a better dimension for us. So we can take this, test equals a times that. No errors. We can do test print test.shape. We can see that works pretty well. For the purpose of this, we'll just call this as the solution, so we can actually just take that and go ahead and put that there. Let's stop it there. So yeah, let's try to just import pdb and then pdb.setTrace. You can just put these sort of wherever you want to put like breaks in your code. So if we try to run that again, you can see we're at this first one, list dot. And what we can do to just skip over to here to the next set trace is that we can press C for continue. And now you can see we're right here, right at this next one. Let's try to step through this again. All right, another error. I think this one's pretty simple. Cannot broadcast these shapes together. We have dimensions 10, 3, 4, 10, 3, 3, and 10, 3, 4. So we can just quickly look at this. Print multiplied dot shape. Print self dot batch c dot shape. Okay, that's pretty clear of what the issue is. For the purposes of this, we'll just go ahead and change this initialization to make the dimensions match. Right, let's try going again. Press C to go here with dot, and then multiplied. All right, so if we move on from this, then that means there's no errors in this code. You can step through that. All right, that line was okay. Try this. All right, we've hit another value error. So what we're looking at is that these shapes are the multiplied is 10, 3, 3, and this row means is 10, 3. You can also just print these to sanity check if you want. Shape. Whoops. Print multiplied dot shape, and then print row means dot shape. All right. So once again, this is sort of like our own little Python interpreter sandbox little area. So we can do like test again. So we're having an issue with broadcasting this lower dimensional shape to this higher dimensional shape. So what we can try to do is expand the dimensions of this. So and you can watch the NumPy video for more details on this. But for now, I'll just try to do expand dims, row means, and then put axis is equal to 2 because we want to try to put a new dimension at the second axis, the second index. Okay, so we can print test.shape. So now we have something. Let's try to do multiplied minus test. We can do test2, doesn't really matter. Okay, test and there's no errors there, so test2.shape. And we can see it's kind of the result that we wanted. So let's implement that. We can just simply write a new line, row means is equal to np.expand dims row means, and then access equals 2. And then let's go ahead and give it a shot. We're here again, continue, and success. So obviously this only helps out with a certain set of cases, but it can still be extremely useful in helping debug really large pieces of code where you don't exactly want to litter your code with a lot of print statements and a lot of different things, and you can also just test out some things in your terminal. Hope this helps.